Hi dear students, welcome back to the mathematics online classes. Now we are going to start the new chapter, that is relations and functions. Very important chapter, relations and the function. Okay, before going to start directly the relations and functions, first of all we come to know that what is the definition of the Cartesian product and ordered pair. Ordered pair and Cartesian product. First of all, what is meant by ordered pair? To come to know that ordered pair, I just take some general example. In day-to-day life, we have know that several relations. What are the relations? We know that a teacher-student relation. We know that father-mother and husband and the wife, friends, like that. The several relations are there. In the same manner, in mathematics also, we are relating few objects or few things. How we are relating? For example, in mathematics, lines, set of lines, parallel lines, perpendicular lines, triangles, and several things you can relate it. So that in the same manner, some relations is there. So how to relate that one? What are the relations are there in mathematics particularly? To come to know that, first of all, ordered pair. How to write the ordered pair? To come to know that ordered pair, I just take the general example. What is the general example? I just take is nothing, but I just consider the two set A and the set B. Already know that what is meant by set. Set is a collection of well-defined objects. Suppose in a set A, there are two colors are there. For example, red color and the blue color. There are two colors. Color combination is that red and blue color contained in a set A. Set B contains an objects. For example, I will say that A, B, C. Three objects are there. How to relation? What is the relation between these two ones? That is nothing but here red is there, blue is there. Two colors are there, and three objects are there in a set B, A, B, C. Now I am going to make the pairs. What are the pairs? We can make red and the object A or whatever. We can make that these are the sets and these are the packs and these are the shares. We can mention it. Okay. So red and A and red and B we can make red and C. These are the possibilities are. Similarly, blue and A, blue and B, and blue and C. This is how we can make the pairs. Now I just write the pairs. What are the pairs? Red means I just write only R, capital R, red, comma A we can make, and red, comma blue R, red, comma B, and similarly red, comma C, like that. And other pairs. What are the other pairs? Blue, comma A, and blue, comma B, and blue, comma C. These are the possible pairs we can make. What are the pairs? Red, comma A, red, comma B, red, comma C. This kind. This is one object. This is another object. Two objects. I am just writing in a ordered pair. That means you say that ordered pair. What is the ordered pair? Ordered pair is nothing but two objects. Now I just go to the general definition. What is the general definition of the ordered pair? Ordered pair is nothing but A and B are the two objects are there. These two objects are listed in a specific order. Listed in a specific order. Listed in a specific order and written in a form of open brackets or open bracket. Written in a form of brackets. Written in a form of open brackets. You can say that open bracket. So this is said to be an ordered pair. What is the ordered pair? Ordered pair is nothing but A and B are the two objects listed in a specific order and written in a open bracket. Written in a open brackets. That means you say that ordered pair. Simple definition. Similarly, this is one example. I think you just already got the meaning of the ordered pair. What is the ordered pair? Ordered pair is two objects are listed in a specific order. Two elements are or two objects A and B are listed in a specific order and written in a open bracket. That is called as a ordered pair. This is one ordered pair. This is another ordered pair. This is ordered pair. This is ordered pair. This is ordered pair. This is ordered. Two objects are there written in a specific order. What is the specific order? First of all, red first belong to the set A. First element belong to the set A. Second element belong to the set B. Like that. Similarly, another example as I say. What is another example? Means, for example, in a daily life, people observe that vehicle numbers, vehicle number plate, that is RTO department used to give that numbers for the vehicle. Each vehicle has a different number. For example, you used to see that your home vehicles, that is particularly KA29 or N or EA, whatever something number is there, and 4 digit, 2 digit, 3 digit, like maximum 4 digit the number they used to give. Some example, for example, N and the 4 digit, maximum 4 digit, lastly or 2 digit, 3 digit number, 1 digit number they used to give. How they used to give? Here also the particular pattern is that. What is the particular pattern? Means I just take the set A contains K is represents that Karnataka, and I just take that MH is represents the Maharashtra, and I just take that GA is represents the state Goa. Now the set B I just consider. What is the set B is consist means I just take the 01 and 29 and 48. Okay, these number I just take 01. For example, if you written KA01, where it comes, each RTO office has the different codes. What are the different codes? Is nothing but KA01 represents the Bangalore Central RTO office. It is represents the Bangalore Central RTO office. For example, KA29 represents the Bagalkot RTO office, and similarly KA48 represents the Jamkhandi RTO office. Like that, different codes for individual RTO office. They have a different codes. In Karnataka, it is present means KA48, 01, 02, like that. So on up to 63 RTO offices are there. Like that, these are the unique codes for the single RTO office. This is Bangalore Central. KA29 means Bagalkot. KA48 is nothing but Jamkhandi. Like that, different codes they used to do. Now I just reading the pair and like that. Similarly, MH01, MH28, like that. Now I'm just going to write the order pair. What are the order pairs we can make? I just write the KA, 01. This is one pair. KA01, and similarly can you write the KA, 29. Next, similarly KA, 48. This is one. These are the order pair. This is one order pair. This is one order pair. This is one order pair. Like that. Is there any other order pairs? Yes. What are the remaining order pairs? I just write the MH01. It might be Mumbai Central. MH48. Exactly, I don't know. MH29 is that, and similarly GA01 and GA29 and GA48. In Goa, these many number of RTO office might not be there, So there is a small. This is Goa is a small state. That means less number of RTO office will be there. I don't need that particular value. Just for an example, I am studying. Nothing to worry. So these are the maximum order pairs we can write. These are said to be a order pair. How many order pairs are there? There are totally 9 order pairs are there. This is how we can write. Here, these elements we are written in or listed in a specific order. What is that specific order? First element is represents the element or object belong to the first set A, and second element belong to the object belong to the second set B, like that. So this is said to be an order pair. Finally, what is an order pair? Order pair is nothing but two objects listed in a specific order and written in a form of open bracket. That is, we say that open brackets. That we can say that as a ordered pair. Ordered pair is very clear. Okay. Now, next thing is Cartesian product. Next thing is Cartesian product. Next definition is Cartesian product. what is meant by Cartesian product? Already we came to know that what is the ordered pair. Cartesian product is nothing but collection of all the ordered pairs. Collection of all the ordered pairs. Collection of all the ordered pairs of two non-empty sets of two non-empty sets, either A and B or P and Q, whatever. This is said to be a Cartesian product. Very important definition. Order pair definition, Cartesian product definition. They used to ask for 1 marks question. Now, what is the Cartesian product? Cartesian product is a collection of all the ordered pairs of two non-empty sets A and B. Two non-empty sets A and B is nothing but set A contains some element, set B contains some element. Non-empty, that means the set which is not a empty set, which is contains at least one element in it. Okay, so this is the question. And one student asked the doubt that non-empty, empty sets are equal. Obviously, empty sets are equal. Okay, we can say that set A is empty, set B is empty. Okay, these two sets are equal, nothing to worry, because same number of elements and the same object is there. What is the same object? There is no object at all, empty. These two sets are equal, nothing to worry. But I am just mentioning that non-empty. What is the meaning of non-empty? Non-empty is nothing but it is not a empty set. It is not a empty set. This is not a empty set. This is not a empty set. And this is not a empty set. This is not a empty set. Non-empty, which is not a empty set. The set which includes some elements in it. Some means nothing but at least one element in it is said to be a non-empty set. Very clearly understand. Don't confuse it. Anyway, I will clear about the Cartesian product. Let two non-empty sets A and B, then collection of all the ordered pairs of a collection of all the ordered pairs of a set is said to be a Cartesian product. We can mention these two non-empty sets at the beginning only, or else add at the end. Nothing to worry. This is the definition of a Cartesian product. Is that clear? Now, after that, simultaneously, you just write the definitions according to my words. Just maintain the notes, write down the notes. These definitions very important definition. Now, Cartesian product is clear. Apart from that, Cartesian product, let's come to another. Here, two non-empty set is there. How to represent the Cartesian product of the two non-empty sets? Here, A and B are the two non-empty sets are there. A and B are two non-empty sets. Cartesian product of A and B, two non-empty sets, is denoted by A into B. Writing method is A into B. Read as A cross B. Read as A cross B. We have to read this is in the manner of A cross B, but writing A into B. Read as A cross B. General form I am just writing of the Cartesian product. What is the Cartesian product of two non-empty set? Cartesian product of two non-empty set is represented by A cross B, which is given by elements A and B. For example, the element A belongs to the set A and the element B belongs to the set B. This is as is written in a set builder form of the Cartesian product. Cartesian product is also a set because collection is the collection of what? Which objects are present in a Cartesian product? Collection of ordered pairs are there. What are the ordered pairs? Ordered pairs is nothing but two objects are arranged in a specific order, listed in a specific order, written in an open run list. Is that clear? So this is said to be a ordered pair, and collection of these all ordered pair. Collection of these all ordered pair. Collection set always denoted by flower bracket. Is that clear? So this is the collection of all the ordered pair is said to be a Cartesian product. Are you clear? Cartesian product. Now this Cartesian product, general form of this written. General form is nothing but set builder form of this written. First element of the order pair. This is said to be the order pair. In that order pair, suppose for example, KA01 is that. Okay, KA01. The first element is belong to the first set A. Set A. Second element belong to the second set B. In that manner only is that. So that it is denoted by A cross B. It is a order pair. In that order pair, first element must belong to the first set, second element must belong to the second set. Is that clear? Second element which not belong to the first set. Don't write that. Here B is not present in the set A. Sometimes it is possible. When it is possible, E is nothing but. For example, if you return A cross E, that means set A cross set B. I am just taking the order pairs to the A cross A only. That means we can make the KA comma AA. We can make it, or we can write the KA comma MH. In that manner also we can write it. Doesn't matter. Depending upon the situation, we have to write it. Okay. Here A cross A also we can write. In this case, A comma A only we can write, or we can write as A comma B. Here A is belong to the set A, B is belong to the set A. Both the elements belong to the set A because single set is the twice I am just taking. This is said to be a Cartesian product of the same set. Similarly, can you write the reverse? Can you write the reverse is nothing but can you write the B cross E? Yes, obviously it is possible. The same example I just write, that is the B comma A. We can write the A comma B, doesn't matter. I'm just write the B comma A. Here, element B belong to the set B and A belong to the set A. Always here, first set, which set you have written firstly, the same. In that set only, you have to choose the object while writing the order pair. While writing the order pair, you have to choose the first element belong to the first set. Here, first set is what? B set is that. So choose the element of the set B. Choose the element from the set B. This is how we write. These are all the general forms or set builder forms of the Cartesian product. Cartesian product collection of all the ordered pairs. Okay, here is the one particular example. Now this is all about the Cartesian product. Now I just take the node. What is the particular node is nothing but here some of the nodes is that. First one is two ordered pairs are equal. For example, we just say that two ordered pairs are equal. If two ordered pairs are equal, then we can say that the two ordered pairs are equal. For example, x comma y is one ordered pair and a comma b is another ordered pair. In a geometry, previously we just written that. For example, in geometry we have taken x comma y is equal to 2 comma 3. Geometry means in an xy coordinate plane. How do we represent the x comma y? This is the x axis and this is the y axis is the. On the x axis x unit, on the y axis y unit. Then these two, where these two points are mutually intersect perpendicularly, that is our x comma y. Here on the x axis 2 unit distance, on the y axis 3 unit distance. This is the point 2 comma 3. Have we projected? Have we plotted this type of points in the xy coordinate plane? Yes. In the same manner, this is x is equal to 2, y is equal to 3. Have we taken? X value is 2, y is 3. Have you taken? Without knowing the knowledge of order pair, you have already used this one. Now, the basic definition I am just telling here. What is the basic definition? This is one order pair, this is one order pair. These two order pairs are equal. When these two order pairs are equal, the first element value is equal to the first element of the second order pair. Two order pairs are there. When these two order pairs are equal, first element of the order pairs are equal. Second element of the order pair must be equal. Then we can say that these two order pairs are equal. Are you clear? When the two order pairs are equal, this is one order pair, this is one order pair. When these two values are equal, when your first element of the order pairs are equal, and as well as second element of the order pairs are equal. First element, second elements are equal. Then we can say that two order pairs are equal. If two order pairs are equal, then write the first element equal to the first element, second element equal to the second element. If given in this manner, first element equal to first element, second element equal to second element, then you can say that two order pairs are equal. Vice versa, we can say that two order pairs are equal whenever their corresponding elements are equal. This is the first note. Next one is number of elements in an order pair. How to find the number of elements in an order pair? number of elements in a order by Cartesian product. Number of elements in a Cartesian product. Number of elements in a Cartesian product. How many elements will be present in a Cartesian product? Already know that number of elements. How to one? So I just rub this. Just need it. I just write. Very simple. So here, number of elements in a Cartesian product I need to find. That means number of elements in a set. We know that. How many elements are present in a set? How many elements are present in a set A? That is cardinality of the set A. What is the n of A? N of A is 3. And what is the n of B? N of B is also 3. Is that clear? Now, you people have written the Cartesian product A cross B is equal to what is written? A, 0, 1. A, 0, 1. A, 29. And similarly A, 48. MH 0, 1. MH 28. MH 48. GA 0, 1. GA 29. GA, 48. You are written. Set A contains 3 elements, set B contains 3 elements. Then what is the number of elements in a Cartesian product A cross B? What is the number of elements present in a Cartesian product A cross B? How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Can I write it as 9 directly? Here is a particular example. Previously, we also taken first example. What is the first example? Set A contains 2 colors, red and blue. That is nothing but n of A is 2. And set B contains 3 objects, A, B, C. N of B is how much? 3. Then you return A cross B. What is the n of A cross B? A, R, A, R, B, R, C, B, A, B, 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 C. Totally how many elements? How many order pairs in this part? That is 6. You can refer the notes. Already mentioned the note. Check it. I have got the 6 elements are present in A cross B. Yes. So therefore, generally, number of elements in a Cartesian product. 2 non-empty sets are there. A and B Cartesian product you are written. N of A cross B written. What is the number of elements? Number of elements which are present in a Cartesian product A cross B is written as N of A into N of B. N of A into N of B. Are you clear? Very simple thing. Now, similarly, this one only we can generalize. What is we can generalize means N of A cross B is equal to M into N, where N of A is M elements and N of B is contains N elements. If N of A contains M element, N of B contains N element, then N of A cross B is equal to N of A into N of B, or simply can write as M into N. Simply can write as M into N. Are you sure? Now, what is the first one? 2 order pairs are equal whenever their corresponding elements are equal. Second one, number of elements in the Cartesian product. N of A cross B is equal to M into N, where M and N are the M is represents the number of elements in the set A and N is represents the number of elements in the set B. This is the one. Now the third note is, now the third one is, previous note we have just taken set A and the set B has the finite number of elements, M number element, N number element, respectively. Suppose third, if any one of the set is infinite, if any one of the set is infinite, either A is infinite or B is infinite, then what is the number of elements which are present in the Cartesian product? That is also infinite number of order pairs will get. That is also infinite number of order pairs. For example, suppose A contains 2 and 3, 2 elements. B contains, we can say that, here I just write the A contains A and B. B contains 1, 2, 3, 4, so on to natural number set. A contains only 2 elements. B contains infinite number, natural numbers contains. Then what we can write the Cartesian product A cross B, make the pairs. How to make the pairs? First element belong to the first set A, comma 1. Second element belong to the second pair A, comma 1, A, comma 2, A, comma 3. A, 4, like that. How many times? A comma 100. Is that 100 in this set? Yes. Unlike that, how many times you have to write? Up to infinity. Similarly, we can write the B comma 1, B comma 2, B comma 3, like that. You can write so many order pairs. Is it a finite set or infinite set? It is a infinite set because infinite number of order pairs we are getting, so that it is a infinite. What is the third note? If any one of the set is infinite, then the Cartesian product is also an infinite. Cartesian product means collection of all the order pairs. That is also infinite number of order pairs are there. Is that clear? Next, we just mention this example, that will be very clear. Okay. Now, next fourth note is, suppose the set A is that some finite set is that set, and we can write the A cross E. Already just know that how to write the A cross E. Both in the order pair A comma B is the both elements we have to choose from the single set. In the same manner, you can write the A cross A cross A. A cross A cross A. This is said to be that Cartesian triplet. This is said to be that Cartesian triplet. This is the Cartesian triplet. Cartesian triplet. How to write this one is nothing but in general I am just writing. There are examples I am just going to take in upcoming video. Nothing to worry. A cross A is nothing but in this video only I will just take the example. A cross A is nothing but A cross B is nothing but you have just taken only two elements A comma B order pair. Two numbers are arranged in a specific manner. Here three set is there, so that three numbers are arranged in a specific order. A comma B comma C, where A is belong to the set A, B is belong to the set A, and as well as C is belong to the set A. This is the set builder form of the Cartesian triplet. This is the set builder form of the Cartesian triplet. Are you clear? Very simple thing is the Cartesian triplet. Is that clear? A cross A is equal to A comma B comma C. Or Cartesian triplet, or another name is there. What is that? Another name is nothing but ordered triplet. Cartesian triplet or ordered triplet. Nothing to it. Whatever the word you can mention it, Cartesian triplet or ordered triplet. This is all about the ordered pair and the Cartesian product. Ordered pair is nothing but two numbers arranged in a specific order and written in a open bracket. And Cartesian product. What is the Cartesian product? Cartesian product is nothing but collection of all the order pairs. Cartesian product is nothing but collection of all the order pairs. It is denoted by A cross B, where A and B are the two non-empty set. Cartesian product is denoted by A cross B. Elements are A comma B, such that A belong to the first set, B belong to the second set. Whatever. If you write P and Q are the two set, P and Q are the two set. I just take the element P comma Q. Here P belong to the set P and Q belong to the set Q. In this manner also you can write. Or is take the P cross Q is equal to A comma B. A belong to the set B. B belong to A belong to the set P. Q belong to P belong to the set Q, like that. Whatever the pattern you can write. General I will just write it. Either remember in this manner or remember in this manner. General form. One of the form you can remember. Representation, whatever. But sets always used to write capital letters. In elements always used to write the small letters, because already know that set representation of the sets. Set builder form and the roster form is that always sets are represented by the capital letters, elements are represented by the small letters. Is that clear? So that elements, small letter, notation of name of the set, always capital letter. Okay. Now based on this definition, Cartesian product and particularly core node, let's take examples. Yes. First example: if x plus 1 comma y minus 2 is equal to 3 comma 1. Find the values of x and y. In the previously People have found out the x and y will depend upon depending upon the several conditions. They used to do the points and they used to do the line, solving the line x and y value. The several manner which is solved. And quadratic equation value which is found out x value. Here we need to find the x and y value. For that, this is one order pair, this is one order pair. These two order pairs are equal. They only given that equal. If these two order pairs are equal, in that case, what is the value of x and y? Already just taken that note. What is the note? Two order pairs are equal means their corresponding elements are equal. Given that here x plus 1 comma y minus 2, this is one order pair, is equal to the 3 comma 1. When these two order pairs are equal, whenever their corresponding elements are equal, first element equal, and you can say that second element equal. That's all. Solve for x. Linear equation involving x. Linear equation involving y. Solve for value. X is equal to 3 minus 1 is 2. X is 2. And y minus 2 is equal to 1 is that. So what is y is equal to? Y is equal to 3. So the required x and y value is 2 and 3 respectively. That's all. This is how they used to ask the question for 1 marks or 2 marks. Very simple. If you return this much, we will get the 1 marks, and we will return this much 1 marks, total 2 marks. Or if they ask 1 marks, final value they used to do the 1 marks. Sometimes they used to do for x value 1 marks correct, and for correct y value 1 marks, total 2 marks. Obviously we used to ask the maximum 1 marks question. Anyway, now in the same manner, let's take the second one. Same. If x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3, then find the values of x and y. Find the values of x and y. Very simple. You can pause the video, solve it. Let us continue. Let us take cross value. Okay. And these two already they have given these two order pairs are equal. Then I am just writing directly x by 3 plus 1 is equal to 5 by 3. Similarly, y minus 2 by 3 is equal to 1 by 3. These two corresponding elements are equal. Whenever two order pairs are equal, solve for x. Linear equation involving one variable. That's all. First of all, x by 3 is equal to 5 by 3 minus 1. Here 3 is the LCM. 5 minus 3 divided by 3. Here x divided by 3. Now I just cancel the 3. What is x is equal to? X is equal to 5 minus 3 is 2. Next, similarly here y is equal to minus 2 by 3 shifting into right hand side. 1 by 3 plus 2 by 3. 3 is the LCM. Both sides are 1 plus 2 is 3. 3 by 3. Y is equal to how much? Y is equal to 1. What are the required x and y value? X value is 2. Y value is 1. For example, would you like to cross verify whether your answer is correct or not? Just substitute x value here. Will you get the 5 by 3 or not? Check it. 2 by 3 plus 1. What is the 2 by 3 plus 1? Look at the 5 by 3. Yes, 3 is the LCM. 2 plus 3 divided by 3. 2 plus 3, 5 by 3. Yes. Similarly, we can cross verify. 1 minus 2 by 3. 1 minus 2 by 3. Look at the 1 by 3. Yes. 3 is the LCM. 3 minus 2 divided by. Obviously, we correct. Sometimes it would be any mistakes here while shifting the term. Instead of writing the plus, we return a minus. Sometimes there is a chances are there to do the mistake. So better to solve very carefully simple examples, because student, on the behalf of student psychology, I will just tell you that always whenever they given the simple problems, very simple problem, in that case there is maximum chances is there to do the mistakes. Is that clear? Because we will get the relax. Whenever we got the relax, that time the maximum chances are there to do the mistakes. So that be careful. Okay. Now let's take the next example. If the set A has 3 elements, if the set A has 3 elements, and the set B is equal to 3, 4, 5, then find the number of then find the number of elements. Find the number of elements in the Cartesian product A cross B. That's the find the number of Cartesian product A cross B. Okay. What the given circuit? Here, read the question carefully. If A has 3 elements and the set B is equal to 3, 4, 5, then find the number of elements in A cross B. They are not asking the elements. What are the elements are belong to the Cartesian product A cross B? They are asking how many elements are present in A cross B. To find the number of elements in A cross B, already know the formula. What is the formula? We know that n of A cross B. What is the n of A cross B? N of A cross B is equal to n of A into n of B. Or is just written simply m into n. What is the m represents? M represents the number of elements in the set E. N represents the number of elements in the set B. Okay. Anyhow, here given. What is given? A has 3 elements. That is nothing but n of A is equal to number of A element. A set has 3 elements. N of A is 3. And set B is given. What is that? B is equal to 3, 4, 5. Then what is the n of B? N of B is also 3. Now we need the n of A cross B is equal to m into n. What is the m value? 3. What is the n value? 3. 3 into 3. 3 is 9. How many elements are present in a Cartesian product A cross B? There are totally 9 elements. 9 elements means 9 order pairs are there. 9 order pairs. For example, set A contains A, B, C. Suppose, not exactly. Then what are the order pairs? A, 3, A, 4, A, 5. Similarly, B, 3, B, 4, like that. How many order pairs are there? 9 order pairs are there. Simply. Are you clear? Very simple problems. Next one, fourth one is if G is equal to 7 and 8 and H is equal to 5, 4 and 2, then find G cross H and as well as H cross G. Then find G cross H and H cross G. Here G and H are the two sets they are given. For these two sets, we need to find the G cross H and H cross G. How to find the G cross H and H cross G? Cartesian product A cross B is there. Set A and set B is given. Instead of the A, G and H is given. First of all, G cross H. How to write the here number of elements is required. Cartesian product only required. Whether this thing is required or number of this thing is required. First, second. Which one is required? First one or second one? Here, first one is required. First one is nothing but what are the elements? Order pair we need to ask. G cross H. General definition we know that. What is the A cross B? A cross B is equal to A comma B, where A belongs to the set A, B belongs to the set B. First element must belong to the first set. So first element is 7. Okay, 7 comma. Second element belongs to the second set. What is the second set? H is 7 comma 5. 7 is fixed. Right pair with all the elements of H. What is that? 7 comma 4. 7 comma 4. Next, similarly, 8 comma 5, 8 comma 4, and 8 comma 2. Counting numbers. How many order pairs have you got? 1, 2, 3, 4, 5, 6. Cross verify 6. Will you write the 6 elements or not? In a G cross H. G cross H. 2 into 3. 2 3s are 6. That's all. Next, one value is over. G cross H is over. H cross G is required. H cross G. Now, first set is H. Second set is G. How to write? No need to worry. After writing the G cross H, we need the H cross G. Just interchange. Just interchange means A comma B is there. Write the B comma A. That's all. Here, this element is present in a cross B. This element present in a B cross A. Here A belong to the set A, B belong to the set B. Here also the same thing. First element belong to the first set, B belong to the set B. Second element belong to the second set, A belong to the set A. So this is the A cross B, this is the B cross A. None of the just interchange. A B written as a B. Or else first fix the 5 and write pair with these two elements. Fix the 4, pair with these two elements as well. Better way is interchange. What we can write 5, 7, 4, 7, 2, 7, 5, 8, 4, 8 and 2, 8. That's it. This is our H cross G. This is 1 marks, this is 1 marks. Total 2 marks. Question. Anyway, next one. Fifth one. Very simple problems are. Let A is equal to 1, 2, 3 and B is equal to 3, 4. C is equal to 4, 5, 6. 4, 5, 6. Then point. First one. A cross B intersection C. Second one is A cross B union A cross C. A cross B union A cross C. Here, little bit they are extended. That is sets concept they are using. Obviously, the Cartesian product is also a set. There is no doubt at all. Here, A cross Cartesian product of A, and second set is what? B intersection C. So I just write that A cross B intersection C. First of all, write the A set. What is the A set? 1, 2, 3 set. Cross B intersection C. Directly I am starting. B intersection C. What is the intersection of two sets? Common. The element which is present in the B as well as C. What is the common element? Only one element is there, that is 4. That's it. Now we choose of the form A cross B manner or P cross Q. What is the P cross Q? First element belong to the first set 1. Second element belong to the second set 1, 2, 2, 3, 4. That's very simple. Is that clear? I just taken the B intersection C directly. First case is over, 1 marks is over. Second case. What is the second case? A cross B is that. A cross B union A cross C. And just write the order pair. This is the set. Order pair is that A cross B. A cross B. Write the elements which are present in A cross B. What are the elements? 1, 3. Fix the 1. Write all the elements. 1, 3. 1, 4. Next 2, 3. 2, 4, next 3, 3 and 3, 4. Nothing to worry. Here is the 3, here is the 3. Common elements is there. So write the A, B. Common element might be that doesn't matter. Here A, E is possible. A is present in the set A. A is present in a set B. It is possibilities that no need to worry. Okay. So here A cross B is over. Union of. Next, A cross C is required. What is the set A? What is the set C? Here, A cross C. So here I am just writing A cross C union A cross C. A set, C set. What are the elements? 1, 4, 1, 5, 1, 6. Similarly, 2, 4, 2, 5, and 2, 6. Similarly, 3, 4, 3, 5, 3, 6. I just written the A cross C. If you need, you just write separately. Okay, nothing to worry. If you need means you can write separately. This is the A cross B, and this is the A cross C. In this manner also you can write. Now, what we need in the second case? Second case, we need A cross B union A cross C. Union of these two sets, A cross B union A cross C. Union of these two sets. What is the union? Union means all the elements of set A, all the elements of set B, common elements going right only once. Right. 1 comma 3. I just write for 1 comma 3. 1 comma 3. Next 1 comma 3 is there in this set. 1 comma 3 is not there. Next 1 comma 4. 2 comma 3. 2 comma 3 is there. Check it. 2 comma 3 in the second set is not there. Anyway. Next 2 comma 4. 2 comma 4 is there. Yes. No need to write it once again. 2 comma 4. Next 3 comma 3. 3 comma 3 is there. In this set 3 comma 3 is not there. Next 3 comma 4. Do you have that 3 comma 4? Yes. No need to write this one 3 comma 4 once again. If you written, nothing to worry, but repeated elements we will write only once. 3 comma. Next 1 comma 4. Already 1 comma 4 is over. 1 comma 5. Write the 1 comma 5. Next 1 comma 6. Next 2 comma 5. 2 comma 6. And 3 comma 5. 3 comma 6. 3 comma 5. 3 comma 6. This is our required second thing. A cross B union A cross C. Okay, very simple problems. Next one is, if A is equal to minus 1 comma 1, then find A cross A. Then find A cross A. Here, Cartesian triplet or ordered triplet they are asking. Set A is given. So, what is the set A? Minus 1 and the plus 1. We need to find the A cross A. To find the A cross A, Cartesian triplet, first of all get the A cross A. Cartesian product you just get it. How? If you need, you just write minus 1 comma 1 cross minus 1 comma 1, or else directly you can write. What are the elements which are present in A cross A? First element picks A, pair with all the elements of the second set. Minus 1 comma minus 1, minus 1 comma plus 1. Next 1 comma minus 1 and 1 comma 1. This is the A cross A is 1. Now this is a single set. We can name this set as a B. Right that we need A cross A. So A set is what? This is the A set. And this is the B set. Here we are writing A cross B. This is the B set. This is the A set is here. Okay, pair. So pair with the first element. First element is minus 1. What is the second element? Second element is nothing but from the B set. What is that B set? Minus 1, minus 1. Is that clear? Similar. This is the minus 1 as it is. Pair with the remaining element. Minus 1 and the plus 1. Minus 1 as it is. 1 minus 1. Next. Minus 1 as it is. Last element 1 comma 1. Minus 1 is 1. Now fix the 1 and write all the elements. What are those? Minus 1, minus 1. 1 minus 1, 1. 1, 1 minus 1. And last element 1, 1, 1. This is the required A cross A. You can mention the bracket or remove. Nothing to worry. Just for your understanding purpose, I just written the bracket. So this is the required A cross A. This is how we have to write. Whenever if they ask a Cartesian triplet, first write the A cross A. Assume this is one set and set A into this set. First fix the one element, write all the elements. Fix the second element, all the elements. If it has two elements. Suppose if it has three elements, one more element 0 will be given. In that case, fix the minus 1, write all these elements. Here, one more value will get it. Is that clear? So that is how we have to write it. Now, I just stop here. The remaining problems will be continued in the next video. And in the next video, I am just going to start with the relation. Here, we have just taken what is the order pair and what is the Cartesian product. Very important person. These two definitions are very important, and whatever the problem till so far we have solved in this chapter, in this video, very important. You must remember all these things, and you must remember these basic problems based on the definition. Okay, and note you have to remember 4 notes are there. 4 notes are also important. Okay, we'll continue in the next video. Thank you.